Hello and welcome everybody into this very first class of A-level course, that is 9702. This is all important topic, but before we start I have to make some important announcements. You can get all past papers from 2002 till 2024. So I have gathered all the past papers for you just in one folder. So you can get that folder, you can WhatsApp me and get those past papers. WhatsApp is in the first comment, and also whatever I write in this lecture definitely will be available in the PDF format. Also you can get that file in PDF format. So to get that file you can WhatsApp me given in the first comment, right? So let's get started. And also don't forget to subscribe my channel, hit the like button and hit the bell icon to get all important coming up lectures, right? And also you think it is worth sharing, share it with one of your friends who need this. Let's get started. Our very first topic is physical quantities, right? Now the question is, what is a physical quantity? We define physical quantity as any measurable quantity is called a physical quantity. For example, somebody asks you length between 2 points. For example, we have a point A and we have a point B, and somebody asks you about the length between 2 points, so from A to B, right? Of course you can tell and you can measure the length between these 2 points with the help of a scale. So definitely this length is a measurable quantity. Somebody asks you about a time interval of an event. Of course you can measure time interval of an event with the help of stopwatch. Somebody asks you about your mass. Of course you can get that mass, and mass is a measurable quantity. Somebody asks you about the weight. Of course weight is a measurable quantity and you can measure it with some help. And somebody asks you about a distance between 2 points, that is also length and can be measured with the help of a scale or some mathematical method with the help of a formula. Definitely distance and displacement and all these quantities are called measurable quantity. So any quantity which is measurable and can be measured with the help of some scale, with the help of some mathematical formula, with the help of some mathematical methods is called a physical quantity, right? So we have some basic physical quantities like length, mass, time, distance, displacement. So all these quantities are called physical quantities because all these quantities are measurable. How we can define this, right? So all measurable quantities are called such as length, mass, time and temperature. Right? Temperature is a physical quantity because we can tell the change in temperature throughout the day, right? We can measure the temperature of a day. So moving on, a physical quantity has two features. One, of course, numerical value, that is called also magnitude, and the other is called a unit in which it is measured, right? Somebody asks you about your mass. So what would you say? I have about 45 kg, I have about 50 kg, so that kilogram or kg is a unit, and that number 45, 60 or 65 is a magnitude, right? A numerical value. So a physical quantity has two features. One is of course numerical value, that is called magnitude, and the other is called a unit in which it is measured, right? Quantity possesses at least two characteristics. In common. 1 is its numerical magnitude, and other is the unit. Is a unit in which it is measured. So a physical quantity has two features. One is called, of course, numerical value, magnitude, and the other is called unit, right? For example, we say that if we want to move from point A to point B, it has a distance of about 10 kilometers. So the number 10 is, of course, a numerical value, is a magnitude, and that kilometer is a unit in which we are measuring the length between two parts, right? So this must be very clear. If you have any question regarding this concept, you can comment down and I'll be answering all important comments and all questions that will be asked in comment sections, right? Moving on, I'm going to write some examples of a physical quantities. Like distance, of course, is a kind of a length between two parts, is measured in meters, right? In meters, kilometers, right? So in general, meters. Time is measured in seconds, right? Mass is measured in kilogram, kg, right? Force measured in newtons, right? So these are some examples of physical quantities in their respective SI unit. I'll explain later what is SI unit, right? So for now, you just have to have the idea in your mind that a physical quantity possesses an SI unit. Without SI unit, a physical quantity is not complete, and a physical quantity is not completely defined without SI unit. This is very, very important, right? Note down that a physical quantity is not completely defined without an SI unit, right? As I have mentioned that a physical quantity possesses two features, numerical value and SI unit. So a physical quantity can never be completely defined without an SI unit, right? Later on, I'll explain what is SI unit and how we define SI unit and how we associate any quantity with that SI unit and how it is associated. Next on, we classified physical quantities into two categories. One is, of course, base quantities, and the other is called derived quantities. Are divided into two categories. One is called base, and the other is called derived quantities. So first I'm going to define and explain what are base quantities, right? So base quantities are the quantities on the basis of which other quantities are expressed. For example, we have a length is a basic quantity, right? Is a base quantity. On the basis of length, we can measure area, like we multiply two lengths of a square, so we can find out area of a square. Like we can find out the volume by using length. So length is a base quantity on the basis of which other quantities are expressed. So in general, all the quantities on the basis of which other quantities are expressed are all called base quantities, right? So we define base quantity as base quantities are the quantities on the basis of which other quantities are expressed are called base quantities. For example, length, mass, time, electric current, temperature, intensity of light, and the amount of a substance. Right? So note down base quantity form the foundation for other quantities. Form the base for other physical quantities, right? So next we have derived quantities. How we define derived quantities? So all the quantities which are made by using base quantities are called derived quantities. For example, area is made by using base quantities like length, right? Volume is a derived quantity. We find out volume by using all other physical quantities which are base quantities. So derived quantities are those quantities which are derived, like it is very clear from the name, it is derived from base quantities. So all the quantities which are made by using base quantities are called derived quantities. So I'm going to write the definition of derived quantities. The quantities that are expressed in terms of base quantities, right? That are expressed in terms of base quantities are called derived quantities. So examples we have like we have area. Area is definitely a derived quantity because area is derived by using all the base quantities, right? Volume, speed, of course, force, work, energy, of course, power, electric charge, and electric potential. So these were all derived quantities which are derived from base quantities, right?